In integer we have int that takes 16 bits, that is 2 bytes. And short is also int only, but it takes 16 bytes. So actually by default int itself means it's a short int. Then you can make an integer also long integer. To store larger size values you can take long, and also there is long available that takes 64 bits. Means this 2 takes 2 bytes, 4 bytes and 8 bytes. Now one important thing we'll discuss here. See, nowadays we are using 64-bit machines. Computers are 64-bit. Before that 32-bit machines were there, and before earlier to that 16-bit machines were there. So mostly in the languages like C, C++, the size of the integer depends on the bit size of a machine. If it is 16-bit machine, then integer takes 2 bytes, that is 16 bits. If it is 64-bit machine, then integer takes 8 bytes, that is 64 bits. So here minimum integer in C++ can take 16-bit, means C++ was introduced when 16-bit machines were existing. People were using 16-bit machines. So that's why minimum size of an integer is 16-bit. Then later came 32-bit. So the integer in those machines became 32-bit, that is 4 bytes and even 8 bytes. So the size of an integer depends on the word size of a machine. Word size means how many bit capacity a machine is having. So based on this, these integer types will be dependent. Float always takes 4 bytes only. Character always takes 1 byte. The size of integer depends on the bit size. Now integer, we are saying that minimum 16 bits it takes. So let us understand in 16 bits how the number is stored. So in 16 bit, what is the minimum or maximum number that we can store? See, 2 power 16 is 65536. So this will range from 0 to 65535. But out of 16 bit, 1 bit is reserved as a sign bit, and remaining 15 bits are used for storing a number. In 16 bits, again the same thing, that is 1 bit is reserved as sign bit and the number is stored in remaining 15 bits. Now in 15 bits, 2 power 15 is 32768. So the range is 0 to 32767. Total 32768. So including positive and negative, it will be from minus 32768 to 32767. This is the range that can be stored in 16 bits. So the minimum number that we can store in this one is minus 32768 and the maximum that we can store is 32767. So this is the range. So as a student, as a programmer, you must know this range. At least for integer you should know the range. Beyond that it may not be easy for remembering. If you are remembering it, that's good. Now one more interesting thing I have to show you that one programmer must know this. Let us talk about negative numbers. How actually a negative number is stored. I said that a sign bit is used. If it is 0, the number is positive. If it is 1, then the number is negative. So how actually a number is stored? So I will take a number and show you. See, the number I want to store is a 10. So 10 means what? 1010, and remaining all bits will be zeros only. So these are 4. Then remaining all 12 bits will be 0 only. So this is a 10 in complete 16 bits. If a minus 10 has to be stored, for positive 10 this is the binary form. For negative 10, first of all this binary form is complemented. So it means all those zeros will become 1 and ones will become 0. So this is 1 1 1 1 1 1 1 1 1 1 1 1 0 1 0 1. So this is complemented form. So we call this as ones complement. This is ones complement. Then 1 is added to this one. So when 1 is added, the result will be 1 plus 1 is 1 0, that is 2 or 10. So 0 and carry 1. So 1 plus 0 is 1 only. This is 1. Then this is 0 1 1 1 1. After adding 1, what we are getting, this is called as 2's complement. So yes, the negative numbers in a language, it is common for any programming language, not just C++. For every programming language, this is a common thing. A negative number is stored in 2's complement form. So what is 2's complement form? The binary form of a number is complemented. So that is 1's complement, plus 1 is added to it, so it becomes 2's complement. So this is minus 10. So you can see that the leading bit, that is this first bit or most significant bit, is 1. So negative numbers are stored in 2's complement form. This is a very important thing one must know. What we have learned just now, the negative number representation, this is common for character data type also and all integer data types also. So all these are integer, just their sizes are different. So we have finished this. Now let us talk about float, that is double data type. Now next is floating point. See, floating point, they support decimal numbers. See, if I have any value like 17.26, then this decimal point is supported by these data types. It is not supported by any one of these except these three. So decimal is allowed there. So how actually it is stored? Why it is called as float? See, if the number is stored as it is with a decimal point between 7 and 2, then it is called as a fixed point decimal. But there is a scientific representation, or there is another method available for representing a decimal, that is called as floating point. So what we do is, we will move the point to the beginning digit. So this is, we are saying floating a point. So you float a point and write it like this, 1726. Then this is not that original number. Then this is into 10 to the power of 2. So 10 to the power of 2 is 100. So multiply that, then again it will become 17.26. Or else it can also be written like this. You can move this float point and make it point after the last digit. So it can be 1726 and then after that it is a point. So it's not a same number. So this is 10 to the power of minus 2. It can be done in either way, but there is some standard followed in the binary form, not in the decimal form. So that you can study by yourself. There is some standard. That standard is called as IEEE standard 754, I guess. Yes, this is a standard available for floating point number. Every electronic device, every programming language, every computer follows the same method for representing decimal numbers, that is floating point representation. So I am just giving you idea in the decimal form, not in binary form. So it is in binary form. So let us understand from decimal only. See, if I follow this method, then if the decimal is before the first digit, then I don't have to write this digit decimal, and I can say 1726 is the number and this is exponent of, that is 10 power, it is 2. So this portion is called as mantissa and this portion is called as exponent. So a floating point number is stored in two parts, that is mantissa part and the exponent part. Otherwise, if you follow decimal, fixed point decimal, then this is integral part and this is the decimal part. So that will have a limited capacity. If it is converted in this form, then you can store large size numbers. So this is the scientific representation. You can write a number e power something. So how actually it is done, if you are interested, you can study it by yourself. So I have given you just the idea. So based on this, a larger size number that can be stored in float, we will see its range, what is the minimum and maximum value that we can store. I will show it practically. Then if you want more precise number, that is high precision number, then you can go for double. It is nothing but same as float, but the precision is high, or long double, the precision is much higher than float. Now the next data type is bool. Bool is for boolean. Boolean values are either true or false. So true is taken as 1 and false is taken as 0. Basically false means 0 and any other number is taken as true. So it means minus 1 is also true, 10 is also true, minus 10 is also true, except 0. This bool data type is actually like integer type only, so it may be taking either 1 byte or 2 bytes, so that's why it is undefined. It depends on the compiler and what the value it will store. Integer value only it will store, but we cannot store negative values there. We have to store only positive number, that is 0 or 1. Right? So instead of taking that data type, you can even say 0 as false and any other number as true. So that will improve the readability of the program if you declare this type of variable. So it makes sense that you are going to store true or false value in this type of variable. Then one more last one is remaining, that is not listed here, that is void. So actually void data type is there, but you cannot declare the variables of type void. This is not allowed. So void means nothing. Then what is the use of void? We can declare a pointer of type void. So we will study about this in some topic. When we discuss about pointers, I'll tell about this. See, one important thing is we have gone into details of the data types. This is must. At least you must know this much about the data types to better utilize them. So just you go through it and try to memorize these things and bring into usage. Now next, practically I will show it on the computer using the IDE. I will write down some code to understand what is the size of the data type and what is the range of the data types. Then next we will move on to variables.